Hello, you're welcome back. All right, so now we are looking at the applications of the application of Newton's second law. All right, and in this application, we're going to be looking at how a lift or elevator actually operates. Okay, so what's a lift? Now, a lift is an interfloor motorized transport system in a story building. Now, there's some story building that, of course, some story building are so long, okay, with many floors, that if someone should actually take a staircase, okay, it might be strenuous taking a staircase. So, such building actually provide a motorized system that carries people from one floor to another, okay. So this motorized system can actually go up or come down. So it actually applies Newton's second law, because according to Newton's second law, we know very well that when there's a force, okay, then definitely there's going to be a change in momentum. When a force is being uh, okay, applied to a system, there's a change in momentum. And still from that Newton's second law, we also know that when there's a force, there's also acceleration, okay, mass times acceleration. So I'm interested in looking at the reaction force. The reaction force on the elevator as actually goes up or down. So that means the elevator have two motions, okay. It's either the motion is upward or the motion is downward. All right, so as I said, there's gonna be want to want to generate formula for the reaction force. The reaction force on this elevator, okay, that actually causes it either to go upward or downward. So now for upward, now first of all, let's look at we are not looking at upward. Let's start by okay, let's look at this scenario where the elevator is at rest or is moving with a constant velocity. Okay, at that point, the reaction force on that elevator is equal to 0, and that is why the elevator is at rest. Okay, so now this is number one case. Now, if the elevator is actually moving upward, if the elevator is moving upward, then the reaction force on the elevator is going to be equal to mass times, okay, the acceleration of the elevator, because the elevator, as the elevator move upward, it actually needs to accelerate. The engine of the elevator needs to accelerate in order to pull on the cable, okay. Then it will definitely accelerate. So A is positive, acceleration is positive, then of course plus G. There's also acceleration due to gravity, because the elevator is not moving horizontally. All right, the elevator is actually moving upward or downward, right? So G must be included in the formula for the reaction force. Then if the elevator is actually coming downward, then that elevator need to decelerate, okay. Let me put the formula this way. Let G comes first. Okay, so mass multiplied by G, then plus acceleration. That is for upward movement of the elevator. But if the elevator is actually coming downward, what happened? Okay, the engine of the elevator must decelerate. The engine of the elevator must decelerate for the elevator to come downward. Okay, so at that point, the reaction force on the elevator is going to be this time around G, but A will be negative. Okay, so please take note of this formula. So this is one of the applications of Newton's second law of motion. All right, so now in this video we are going to be solving some question. Okay, we're going to uh, tackle some problems and their solutions. All right, So I'll go straight to questions. I think I have them. Okay, let me just maximize that so that it will. Okay, I hope it can be seen now. All right. So the very first question I have here is: a force of 100 newtons is used to kick a football of mass 0.8 kg. So so the force supplied is 100 newton, and of course it's used to kick a football of mass 0.8 kg. All right, then let's proceed with the question. Find the velocity with which the ball moves. Okay, that means it's actually noted that this ball was kicked from rest, so the initial velocity is 0. So we're looking for the final velocity, okay, to which the ball actually moved from rest. Okay, the ball was at rest. So the velocity to which the ball moves, if it takes 0.8 seconds, if the time is 0.8 seconds. Okay, so which formula goes with these parameters? This is definitely going to be Newton's second law. Okay, F is equal to m v minus u, then divided by t. Okay, so of course F is 100 divided by the mass, which is 0.8, open bracket, v minus u, which is 0, then divided by the time, still 0.8. So it's easy for 0.8 to cancel 0.8. V minus 0 is actually v. Okay, so I can now have that v is equal to 100 meter per second. Okay, that's Newton's second law. Let's look at another question. Okay, so let me also increase that. Shall we go? This one goes like this. A rope is being used to pull a mass of 10 kg vertically upward. So the mass is 10 kg and it's going vertically upward. Okay, determine the tension of the rope. If starting from rest, the mass acquires a velocity of 4 meters per second in 8 seconds. Okay, so the question is determine the tension in the rope. If starting from rest, the mass acquires a velocity. So the velocity acquired by the mass is 10 meters per second. Okay, and they say starting from rest. Starting from rest, that's okay. That's u is equal to 0, and the time for that to actually happen is 8 seconds. All right, so tension is also force. Please take note. Tension is a type of force on a rope, and we're still gonna apply the formula for Newton's second law for force. Okay, so I have 10 bracket open, 10 then minus 0 divided by 8, right? So this is going to be equal to 10 minus 0 is 10. 10 times 10 is 100. So having 100 all over 8. So 100 all over 8 is what? Okay, let's do that. 100 all over 8. Okay, 100 divided by 8. So what do we have? 12.5. So the tension is 12.5 Newton. All right, so let me clear up so that we continue. Another question. Okay, so let me still Maximize this. A body of mass 12 kg traveling at 4.2 meter per second collides with another body. Second body of mass 18 kg. So this is definitely new, the third law and inelastic collision, if you can remember. Okay, so the first body is M1 and we're told it's 12 kg. I've solved this question. I think I did solve this question. Yes, or have I not? And that 12 kg, okay, was actually traveling with an initial velocity of 4.2 meter per second. Now it now collides with the second body of mass 18 kg, and that's M2, 18 kg, and the 18 kg is at rest. So of course, we are looking for their final velocity. We've done this, we've evaluated this question before. From Newton, third law, inelastic collision, M1U1 is equal to M2U2. Okay, then bracket M1 plus M2, then multiply by V. So we've done this before. This is going to be 12 times 4.2, then plus 18 times 0 is equal to 12 plus 18. So I've done this before, though. I don't have to repeat that again. Okay. Another question. What force has to be exerted on a mass of 60 kg to give it an acceleration of 10 meters per second vertically upward? This is more like what you get, okay, on elevator. So of course, if that force need to pull this mass upward, then definitely what you have is the acceleration plus the acceleration due to gravity. Mass times acceleration plus the acceleration due to gravity, right? Please pardon me. So this is going to be equal to, please. All right, mass is 60 and the acceleration is 10. So that's going to be 60 plus 10 plus 10. So that's going to be 60 times 100, which is 600 Newton. Okay, so I hope that is well understood. What did I do? Okay. Why is it different from... Okay, can you imagine? Imagine me making a very big mistake. 10 plus 10. Just imagine this. Okay, please pardon me for the mistake. 10 plus 10 is 20, right? So I'm having a 60 times 20, which is 1,200. 1,200 Newton. Okay, another question. A body of mass 4 kg resting on a smooth horizontal plane is simultaneously acted upon by two perpendicular forces, 6 Newton and 8 Newton. Calculate the acceleration. So, of course, to get acceleration, we use the formula mass force is equal to mass times acceleration, right? But it happened that the force that is actually acting on on that body, okay, are actually two forces and they are perpendicular to each other. So you need to get the result out. Now we've treated vectors before. If two forces are perpendicular, okay, to get the resultant force, we apply Pythagoras theorem. So that's going to be equal to h squared, right, plus c squared equal to, so what What's the mass? The mass is 4 kg. 4 times the acceleration. I'm looking for the acceleration. All right, so of course, this 64 plus 36 equal to 4a. 64 plus 36 is 100 equal to 4a. Then that square root of 100 is 10. Is equal to 4a. So now a now is going to be equal to 10 all over 4. What do we have? 10 divided by 4. 2.5. Then the SI unit of acceleration is meter per second square, or mx raised to the power of minus 2. Okay. Okay. Expand that. A body weighing 80 newtons standing in an elevator that is about to move. The force exerted by the floor on the body as the elevator moves upward with an acceleration of 5 meters per second square. So elevator formula, upward. Remember that now, right? Upward. So this is the force on the elevator as it moves upward. Okay. Now, already the acceleration has already been given, 5 meters per second. But what I don't know is the mass, and at the same time, gravity is constant. I don't know the mass. Okay, so now weight is always given as mg. Weight is always mass times acceleration to gravity. Please take note of that. So I can get the mass from weight. So mass is going to be equal to weight divided by acceleration due to gravity. So the weight from the question is the body is weighing 80 Newton. Okay, so that's going to be 80 divided by acceleration due to gravity, which is 10. That actually gives us 80 divided by 10. That's going to be 8 kg. So F now is going to be equal to 8 kg, then times 5 acceleration due to gravity, then plus 5 the acceleration of the elevator, then g, which is 10 acceleration due to gravity. So everything is going to be equal to 8 times 15. So 8 times 15, that's 120. So the force on the elevator is 120 Newton. Okay, so I think I'm gonna stop here. All right, so see you in the next video. Thank you very much.